All right. I think we're looking pretty good. Plug in my laptop. All right. So yesterday we introduced the bridge pattern in a very simplified way, and we also mentioned that the bridge pattern is one of the design patterns that has a lot of different interpretations out there, but ultimately is a structural pattern that aims to bridge one abstraction to another. And like all the structural patterns, that lets you architect things without having to commit too heavily to implementation details. So we can really get some good functionality and see an application architecture evolve without having to do a lot of work that ultimately might have to be redone or retooled. So let's move everything in order to do. Just to go over the kata real quickly. As usual, we committed to a Git repo. So when we created a simple UI, we created our abstractions, and we bridged the two. We added some base functionality, and then we created some concrete implementations. So these steps don't really give a lot of credit to how much the pattern really accomplishes, and this is really the point here, because a lot of the places that try to define the bridge pattern go way overboard in detail, and it shouldn't take 16, 17 classes to get a kata down. All right. And then we applied the bridge pattern to our game. So the abstractions we chose were the player object that we've been working on, and this guy keeps growing in functionality every week. We wanted to introduce the idea of inventory. So we created a bridge from our player inventory to the basic game inventory, meaning that items within the game. And after the camera went off, I added a bit of structure, nothing that we haven't done already, but we started off with our abstraction just being an interface that inherited from the iGame object. I went ahead and baked that into a base inventory item that inherits from the iInventory interface, which in turn inherits from the iGame object. So I went ahead and implemented a lot of the things that the iGame object expects. Things that I don't want to have to redefine in anything that derives from the base inventory item. We had our inventory types. I added player keepsake, just to kind of say we're going to plan for this. So a wearable is going to be an item that the user can put on their body. A weapon is going to be something they can use to fight. And then a keepsake is going to be something that's simply in their inventory. And we want all these things to add to the player's abilities or modify them in some way. So a keepsake, in terms of our zombie survival game, might be like a lucky rabbit's foot. And the lucky rabbit's foot might add some plus ability to one of the stats, but you can't wear it, you can't use it as a weapon, but we still want it to have all these qualities. So where the bridge pattern meets real life is I created this bridge from our player inventory item to our base inventory item, and I placed that inside of our player as an I list of player inventory items. So we've got that basic concept of inventory. The player can add anything to their inventory that is derived from the player inventory item. So they can have a weapon in their inventory, and it isn't until they go to do something with it that we care what type of inventory item it is. The other thing that I did after the lights went off is I created a concept of a player anatomy, which is an enum that has head, torso, arms, legs, hands, feet, ears, fingers, offhand. It's like a shield type item, and then back. So things like backpack. Oh, and I'll tell you what else we'll do. Shouldn't really matter, but we will do waist. All right. So I extended the player inventory item and created this concept of a wearable, player wearable. And then inside of player, I said, make me a dictionary where the key is the anatomy, so there can only be one entry per anatomy item, and a player wearable item will go there. And the way we want to constrain player wearable is that anything that inherits this should define the player anatomy. And so if we created a helmet, we want that concrete implementation, the helmet, to say, I'm one on the head. Okay. The other thing that we did for the player inventory item is we gave it these boost booleans, so that we just flags that we can check. So can this item boost the HP? Can it boost healing? Can it boost repair? Can it boost attack? Can it boost negotiate? These being the basic actions we have in our game. This is going to be a pretty straightforward check we can do. And if it can do these things, we might want to go ahead and process or report back what that boost would be or apply it to something. And just to highlight the bridge pattern again, inside weapon and wearable, we really don't have anything, and we don't need anything. It's a structural pattern, and so the benefit that it gives us is we can define very little outside of these abstractions, but they're going to help us give shape and really think through our player. So by doing those very simple extensions, we now have an inventory, we've got an outfit, we have a weapon. Okay. There's also, if we didn't cover this before, we'll say this now. There's a concept of being able to add an inventory item and remove an inventory item. And to show how this might be used in a very, very simple implementation, I think I'll do this. So when you create a new player, let's say of type carpenter, and when the carpenter is asked to fight, the strategy is going to be called. So let's open that up. And that strategy is going to say, this costs the carpenter 2 stamina, so 2 turns, and it returns 7. So if we come back out to the player, The result of asking the carpenter to fight is that he's going to return a damage of 7. Well, we can also say, okay, add on to that inventory where, and we're using link for this, boost attack. So we're saying that inside the inventory, give me back everything where the item can boost the attack. And inside my inventory, let's go look at this again. And what we have access to inside of whatever this is going to be is going to be the attack boost. So to be able to say, calculate everything in my inventory that would boost my attack and add it on to whatever the value of my base character is. So we're going to be using that flag as opposed to a condition that looks for, let's just say, boost is greater than 0. We don't want to make those calculations in line. We want to be able to just check the flag, and if it exists, sum up the results of that method. We can do the same thing for wearable. We can do the same thing for weapon. There's not really anything in weapon right now, but because all of these things are coming from the base player inventory item, we can always say inside player, when they fight, var weapon boost is equal to weapon attack boost, and if it can, we want to boost the attack, otherwise return back 0. Oops. All right, so in one implementation, we want to go into the inventory and just run a link query and sum up all the things that we have. Same thing with the outfit. Give me a sum of all the things that can boost my attack and add them here. For the weapon, take a slightly different approach. And we say, if the weapon can boost the attack, give me that, otherwise return 0 and add it here. So by doing this abstraction without writing any code and without having any specific weapons created, we can still think through and work out the logic for our application and the architecture. So I'm going to leave that there. Then I'm going to say var outfit boost is equal to outfit. Let's see if it contains value. Gives me what I want. No. I want to